My name is Christina White. I'm a professor at the University of Illinois, and my students and I can best be described as molecular surgeons. So we're trying to develop tools which are known as catalysts that will enable us to take small molecules and with surgical precision replace CH bonds to CO, CN, or CC. And this can dramatically change the properties of small molecules. So small molecules are all around us. They are the drugs that we take. They're the components in the food that we eat that gives it flavor. They're the components in the fragrances that we use that gives them smell. And they are the hydrocarbons in the oils that we use. So this is a small molecule. This is the molecule that gives oranges its very characteristic taste. And this small molecule has a hydrocarbon core that is made up of carbon, and carbon-hydrogen bonds. And this is a very strong, very inert core. Let's say that we can break this carbon-hydrogen bond and now replace it with a carbon-oxygen bond. This now will no longer taste like oranges, but will instead taste like grapefruit. There are many examples from the pharmaceutical realm as well. So you can take 6-deoxyerythromycin A, and now if you take this CH bond and replace it with a carbon-oxygen bond, you have converted a molecule that was not a very good drug to something that is a very good antibiotic. So you can imagine the challenge of trying to do this in the laboratory is that first, these are very inert types of bonds, and there's a lot of them. So in nature does do this with very complex catalysts, ones that don't work really well outside the realm of nature, and ones that are very specific. So there's one specific enzyme for each of these small molecules that you use. And really, people didn't think that you could do it any other way other than nature's way, until we discovered this catalyst, which is known as iron PDP. So iron PDP can go in and with surgical precision select one CH bond across a range of complex molecules and convert it to carbon-oxygen bonds. We now have 3 commercial catalysts. They're sold at major companies, chemical companies, and they're shown here in the back. These catalysts are routinely used and bought by academic scientists as well as industrial scientists to expedite drug discovery and drug manufacturing processes. Chemistry is a very unique science because it allows you to be very creative. So, this catalyst has never been made before. No one has ever made it. It doesn't exist in nature. And so it allows you to create things working within the laws, obviously, of nature, but things that don't exist in nature. Other sciences, many times, have more of an observational quality to them. You're observing what's happening in nature. You're trying to elucidate what's happening in nature. Chemistry is a very creative science, and I think that's the part that really attracted me. So I think Illinois has had a strong tradition of trying to enable scientists to have no barriers towards their science other than their own creativity. Ultimately our vision is that we take any complex molecule and can choose any of the CH bonds that are shown here and selectively and predictably pluck one off and put in oxygen, nitrogen, or carbon at will. And this is a very challenging goal. We're still working towards it, but I think with the team that I've assembled here and that we can attract here, I think it's definitely a possibility, and it's something that we can make this sort of vision into a reality.